Yeah, once again, thanks everyone for joining. Today we're presenting on the topic you see on the screen, which is scaling developer productivity with Temporal Nexus and Duolingo. And to go a bit more into how this webinar is going to run, if you could just go to the next slide. We have, oh, just one back if you don't mind. Awesome, thanks. Yeah, during the webinar, we love questions and we want to make this as engaging as possible. So feel free to use the Q&A button. You'll see it at the bottom there, kind of towards the right, to ask questions. If you ask them there, we'll be able to either answer them live during the Q&A portion or throughout the webinar. One of us will try to get to you. And then if we don't get to it during the webinar, we'll just we'll respond to you afterwards and make sure you get your answer. And then we also have our Slack channel if you have further questions or want to learn more about other topics or this webinar in particular. And then lastly, just to call out, we have our community newsletter where you can learn about other cool opportunities like this. So we have tons of webinars, tons of events, and exciting things coming up. So yeah, with that, I'll go ahead and introduce our host for today. So we have Phil Prasek. He is a senior staff product manager at Temporal. He works on our Temporal Nexus product, among other things. And then joining us from Duolingo is Jihao Wang, who is a senior software engineer and works on the cloud team. And we're going to get to hear from both of them today and hear their journey with Temporal Nexus and Duolingo and how they use it as well. So yeah, it should be super exciting. And then next slide for the agenda. We'll just start by giving a quick overview of Temporal Nexus. We'll let Jihao present on how Duolingo use Temporal for their own business. We'll get into a live demo, cover the roadmap for Nexus, and then end with the Q&A portion. So with that, I'll pass it off to you, Phil, to get us kicked off.
Awesome. Thanks, Cubby. So, today, Nexus has been focused on connecting temporal apps across isolated namespaces, within temporal. And, you might ask, like, well, why do I need multiple namespaces? Why can't I just have a single large monolithic namespace that all my teams can live in? And you can, and it actually works pretty well. But, when that page rolls in at 3 a.m. due to a misbehaving worker, it sure is nice to have that blast radius for that incident isolated to just your team. Or if you have like sensitive, PCI or PII data, you might want to secure that in a separate namespace with a separate encryption key and kind of separate access controls and to get that locked down. So really, like in an ideal world, each team can have their own namespace for improved security, modularity, fault isolation, and a clean sense of ownership. And if we look at, kind of like a typical application with multiple temporal-based services, the question really becomes, how do they communicate? But more importantly, does the form of communication enable durable execution in the way we would want with integrated observability and execution debugging and reliability and so on? And so in the past, there have been a couple options, child workflows, or an activity wrapper that targets a remote namespace directly, but both of these have notable limitations. Um, in general, workflow to workflow is just a leaky abstraction. The caller has to know the target namespace, the target task queue, all the workflow policy options. Somehow the caller's on the hook for maintaining workflow ID uniqueness in the target namespace. These are all things that the caller shouldn't have to know, and things the service provider definitely doesn't want the caller messing with. Additionally, child workflows have to be in the same namespace in Temporal Cloud, meaning that we're back to that, large monolithic namespace. Everybody's got access to everything, and we don't have clean API contracts across these boundaries. If you use an activity wrapper to target a remote namespace directly, you can do that. Use an MTLS client cert that you have to kind of have for every single target namespace you want to talk to, and you have to rotate them. And you have to get full namespace write access on all those target namespaces, which is pretty like overly permissive as far as access goes. So not a great security posture. And then on top of it, you have to write these activity wrappers. You have to run them in every namespace. You don't have integrated observability. And this is just like a naive example where you're kind of synchronously blocking on potentially like a long running, billing workflow that's going to be doing a bunch of steps and that kind of a thing. And so what you would actually see in practice for, async results is another activity wrapper back to the caller that sends a signal, and you have to have full namespace right on that side as well. And some folks will, be like, hey, this is just not cool. So I'm going to add a bespoke gateway in the middle. I'm going to spin up my own HTTP endpoint that exposes a more limited API surface area, and I can control who has access to this thing. And then only the gateway can talk to the individual namespaces. But what folks have found is that these gateways are not durable. You basically have not great debugging across services because it's making this additional hop. You have to do like log correlation, all this stuff. It's another service you have to manage and maintain and patch and update, and it becomes a single point of operational risk. So now with Nexus, you get a fully integrated temporal experience where you can spin up Nexus handlers in your temporal workers using the temporal SDK, often just right alongside your workflows and activities. And you can expose a clean service contract, a subset of the overall capabilities of your namespace, for other teams to use via a Nexus endpoint, which is a reverse proxy for your Nexus services that's fully managed by Temporal. And you create them in the Nexus registry, and we use the same queue-based worker architecture that you're using for your workflows and activities today. That's polling Temporal for work. So you get automatic load balancing for free. We have built-in retries, exponential backoff, rate limiting, circuit breaking, etc., as well as fully integrated execution, debugging, and observability. And then in Temporal Cloud, the Nexus registry is global across your entire account, across all namespaces. And we have inside of Temporal Cloud a global MTLS secured Envoy mesh that connects all the namespaces together within and across regions, across clouds, with built-in access control, metrics, and auditing. So Nexus is GA, and you can use it to connect workflows within Temporal today. You can make calls from caller workflows, and you can basically have Nexus handlers in your temporal workers. You can develop in pretty much all the SDKs. Go and Java are GA. Python's in preview. It's about to go GA, literally in a couple weeks. So if you're using Python, definitely check that out. Preview is actually good for production use cases, gets formal support, all that kind of thing. So, and then .NET and TypeScript are in pre-release, and those will be moving to GA soon, along with Ruby. And then on the ops side, you get that integrated observability and execution debugging. And then in Temporal Cloud, you get that multi-region, multi-cloud connectivity, built-in access controls and audit logs, and it's compatible with our HA support around like multi-region namespaces and that kind of a thing. So with that, I'm going to hand it over to Jihao, and he's going to walk us through how Duolingo is using Temporal and Nexus.
Okay. Hello, everyone. So my name is Jihao. Yeah, I'll share my screen right now. You can see my screen. All right.
Coming through.
Cool. So my name is Jihao. So I'm a senior software engineer at Duolingo. I've been working at Duolingo for 3 years. I'm on a team called Cloud Operations. So today I'm going to talk about like how we have enabled the self-service infrastructure leveraging Temporal and Temporal Nexus. So my team, Cloud Operations team, manage all the cloud infrastructure on AWS and provide engineer with toolings and automation they need to ship features safely and reliably. So sometimes we have to perform really high risk and complex operations that product engineer wouldn't handle themselves. Either because they don't have the necessary permission or they don't feel comfortable doing them. So those requests usually come in as Slack messages or Jira ticket. We often have to manually copy paste the information and perform ClickUps. And most of the time we need to use elevated LLM roles. So as Duolingo scale over time, we need to make sure our team scale with it as well. So we've scaled ourselves by building a lot of automated temporal workflows for repeatable infrastructure tasks. For example, like we want to recite a database, or we would delay some like resource, or like a combination of a lot of things. Those workflow run in our team's namespace with really strict access control. So no other engineer outside our team can trigger a workflow. For example, delete a database, right? This is disastrous. Um, However, we still face some challenges, right? Even if we have those workflow, many people are not aware of that we have those temporal workflow. And we found that a significant amount of time is still spent on communication and manual copy paste tasks. For example, like we sometimes request something, but we have to send a Slack messages to confirm that it is okay to do it right now or later. Sometimes when they provide like a missing information or incorrect information, we have to double confirm with them. So a lot of a lot of time is wasted on communication. So what we actually wanted is a system where engineer can trigger the workflow themselves instead of us triggering that. So we don't have to handle the copy paste work, right? The workflow should automatically fail if any parameter are incorrect. For example, sometimes they give us like maybe they give us like a instance identifier. However, they should give us a class identifier. So this workflow should automatically fail if they provide the wrong information without requiring us to manually notify them, right? So, however, we still want to maintain the control of the flow. For example, so like I mentioned, we don't want people to trigger a workflow in our namespace. That is too dangerous. So for the approval process, if you are familiar with Temporal, this can be easily implemented using signals. This is why Temporal is really good for like human in the loop workflow. So you can just implement within just a couple lines of code. So if you want, engineer can trigger a workflow themselves. Basically, we need to grant them the right access to the namespace so they can trigger the workflow. However, like I mentioned, we don't want people outside our team to be able to, like, for example, send a signal to approve the workflow. So this means no right access to this namespace. So there's a conflict, right? So the hardest part is access control. The key constraint is the access to our CloudOps namespace must be restricted. Then the question becomes, how can we expose those workflow in a safe manner? So the solution is definitely cross namespace communication because we don't want people to access to our namespace, but we also don't want to change anything within our existing workflow or workers. So we were thinking about creating like a central gateway namespace that everyone can access to, but how should they communicate, right? However, we got lucky because at that time we were thinking about this issue. Nexus came out. So thanks to Temporal Nexus, we don't have to build our own solution. For example, if we were to build our own solution, it would probably work, but we wouldn't benefit from the building features like the Nexus provides, such as like retry, like temporal workflow, right? I think it would be pretty ironic to implement our own retry mechanism while using temporal workflow, right? Because the benefits of using temporal workflows to leverage those building functions so we can focus our business logic. So we set up a Nexus endpoint called CloudOps. However, I was immediately confused because you can only specify one task queue for a Nexus endpoint, right? But we have multiple workers within our namespace. So I asked a question in the community Slack, and thanks to the Nexus team, they helped me figure out like a proper pattern for setting this up. So the answer is that you can set up a worker specifically for routing workflow for different task queues. I wasn't aware of this. I think now they update the documentation. I will show you some code examples in just a minute. So the access problem is now resolved, right? So the engineering tools outside our team can view the progress of the CloudOps workflow because they all have the read access. However, they cannot trigger or signal the workflow to approve or deny it just because they don't have the right access. So we provide like a great transparency on the progress of the workflow, but we have the fully control of that. So this is really good. Now let's see whether we have solved all the challenges. However, well, not really. So we really love Temporal UI, but asking people to enter the raw JSON input isn't a user-friendly way for engineers, right? Especially for like infrastructure requests. And they need to know like what they need to provide, right? So like simply opening the Temporal UI does not provide that. So what we want is a simple web interface where engineer can trigger temporal workflows, and the site should be easy, and also the site should be easy for backend engineer to maintain. So we want something like JSON or like YAML based tool to render the UI. We also some like validation to catch the error before execution. Um, so the solution is an open source framework called React JSON schema form, and I simply asked AI to build the portal for me in just a few days. However, as of now, temporal workflow or Nexus operation can only be triggered via like SDK, CLI, or the UI. So how do we tackle this? That is not so hard. So you can simply build a microservice. So I propose a very lightweight microservice that serves as a gateway for the front-end client to trigger workflow. I mean, just because we don't want to run like a server render UI, so it's really just static page. So we want to leverage HTTP requests. I mean, we're back engineer, right? So basically, we propose like a microservice for that. So with that, this is what the system look like in the end. So the temporal self-service portal serves the UI. So it uses the JSON schema to render the UI. An engineer can select a workflow, fill in the parameters, which I'm going to show later. And then they can trigger the workflow directly from the portal. Under the hood, the portal triggers the router workflow in the gateway namespace through the gateway backend microservice. And the gateway router workflow initializes the Nexus client and trigger the corresponding Nexus operation. And within the namespace, so within, for example, like CI/CD or Cloud of namespace, in each namespace, there's a router worker that routes the workflow to their target task queue. So you don't have to modify any existing worker. You can just add the router and route the workflow to that. So now I'm going to dive some detail into each part. So within the gateway namespace, we created a router workflow. So inside the workflow, the logic is pretty simple. We basically initialize the Nexus client and call the corresponding Nexus operation based on the input. So we have created a naming convention. Basically, the Nexus operation should be the workflow name. So we don't have a lot of confusion, and this should be unique. Within the namespace. So for example, in the CloudOps namespace, we only need to implement the router worker without modifying any existing workers. The main logic is basically specify the operational name, the operation name, which map to the workflow type according to our naming convention, and route it to appropriate task queue. So we basically build a wrapper function so you can easily define your operations with just a few lines of code. And nowadays with AI, they could probably just write it in just 1 minute. In the self-service portal, we make sure that all the registered workflow include the necessary information required to call the router workflow. For example, we need to know the namespace, we need to know the task queue. Again, so with AI, a lot of things could just automatically, read your code and generate those informations. We leverage open source framework I mentioned earlier to render the form and capture the form data. So this then become the input for the target workflow. We basically wrap everything and send to the router, and the router will, trigger the target operation. We have defined a schema for engineer to register the workflow in the self-service portal. And, you don't have to write this manually because usually AI can just read your workflow code and generate this JSON config for you. As we create more and more self-service workflows, we have realized that this might become a new paradigm, which I call it like workflow as a service. Team now build reusable, durable workflows that can be shared across teams via Nexus or on top of Nexus HTTPS. So the client are not limited to our, the front-end portal. For example, like we have an internal Duolingo AI Slack bot that can trigger an agentic temporal workflow to modify your code and generate a pull request. And this is probably like one of the most popular like temporal workflow within Duolingo right now. We have also abstract some shared functionality into reusable Nexus operations. For example, we abstract the Slack notification functionality into Nexus operation. So team don't have to for example, they don't have to install SDK, Slack SDK in their workers or manage any API keys. They simply can call Nexus operation to send the Slack notifications. This is just like calling an API, right? I think this is what Nexus is designed for. This allowed them to focus entirely on their implementation, the business logic of their workflow, without worrying about how the Slack notification are implemented, how the API key is configured, or like managing the upgrade of the library. This also make us easy to to test and roll out changes on our end. So we as for example, as the owner of this Slack notification features, we can easily test it and upgrade it as long as we keep the contract same. Um, yeah, so this is why I consider Nexus can enable that can enable workflow as a service. The Nexus operation parameter schema becomes a contract between you and your end users. So this project has saved a significant number of engineering hours on a lot of time-consuming tasks. And most importantly, we didn't compromise security. In fact, automating the process, we're less likely to cause issues. And some workflows have been pretty instrumental in several outages at Duolingo. At first, we just wanted a solution to address the problem our team was facing. However, now more and more teams are adding workflow to this self-service platform, empowering engineers to their day-to-day life. Something we didn't expect that this project has also driven adoption of Temporal at Duolingo to some extent. So Temporal started as a CloudOps tool for our team, but now, so like I mentioned, like before, so even we have some internal workflow, nobody is aware of Temporal. But now since we have this platform, a lot of people, are becoming aware of that, and more team are going to try that. So this has become an organization-wide workflow platform. We didn't set any OKR specifically for Temporal, but the supporting infrastructure has grown organically across team because many team are contributing to shared code, shared Nexus operations, like a lot of workflows. We even create a temporal workflow to bootstrap a new temporal workflow, right? This is pretty cool. So now engineers can ship their first temporal workflow within just like 1 or 2 days to production. This really drives the adoption of Temporal at Duolingo. So now I'm going to do a demo of our self-service portal. I'm going to stop sharing my slides and share another screen. Okay, just 1 second. Cool. I'm going to share my screen here. Cool. So this is our self-service portal I created. So as you can see here, we have a lot of like workflow here. If you click one of the workflow, for example, like Bootstrap Temporal workflow, right? So we have the parameter here. We also recently added a feature that like automatically load this like the enum values. Basically, we can do a lot of fancy stuff on top of that. And actually, this is backed up by Temporal workflow as well. So basically, and also like all the things you see is driven by like JSON schema. So this is very backend engineer or platform engineer friendly. So today I'm going to present a like example to delete a database. So this is like a very common use case. So previously, they have to send us a message or like do a ticket, and then we just copy paste it or like open Windows console to delete the cluster. It will probably take 20 minutes to delete it, and then we're gonna go back and forth, check it, and select them to inform them. So how we're gonna do today? Basically, if you search like delete RDS cluster instance, so for example, this is a cluster I'm going to delete, right? So if I were like engineer, how are we gonna do that? So for example, I can simply search this. I'm going to delete this cluster. I can skip the final snapshot because I know this is okay. I'm going to assign this to myself. I mean, this could be optional, so we're going to automatically assign if we don't set it. So we ask people to create like, like ticket number. So now I'm going to just put a random ticket here. So for this demo, I'm not going to do dry run, but we usually recommend people to dry run the workflow first so we can, basically run some validation. For example, this cluster does not exist, right? So this can be captured in the dry run mode. But just because I know this is going to work, I'm going to skip dry run. I'm going to review my parameter. I can also, if you're interested, you can also see the detail of the input for the workflow. And then I can just hit confirm. Cool. Let me view the workflow now. Here it is. So the workflow has been triggered, right? So as you can see here, I have an activity. It's like a dummy activity. It says like wait for signal. Basically, the workflow is now pending. So you can imagine that, okay, our team, some member will receive a Slack notification saying, hey, please approve this request. This cluster exists. This is the ticket number. Please take a look and approve this request. We can approve this request via signal. I can set a signal saying, I'm going to confirm deletion. I'm going to put like an empty database because this doesn't matter. I can just submit it. And then the workflow continues. And that's it. And the workflow will handle the rest. Basically, delete the instance first, wait for the delete, and after that, they're going to delete the cluster and also report to CloudOps team and also whoever triggered the workflow say, oh, the cluster has been deleted. This will take probably 20 minutes. And now I'm going to show you how how this actually works in the Nexus context. As you can see here, so basically the workflow is in the CloudOps namespace. If you click this link, it will take to the gateway namespace I mentioned. So basically, the workflow trigger a workflow. So from the portal, it triggers a router workflow here. It basically just call another call an operation which eventually trigger like CloudOps delete RDS workflow. So this is the parameter I have set. It's pretty easy. So the router workflow is just a very simple wrapper that called another namespace workflow. And once when the workflow complete, you will see like the result here. I can show some of the examples here. For example, we have the other day we deleted another database, right? So this is the output saying that, okay, this is dry run, but it also returned the output. Yeah, so this is how it works. I'm also going to show you how the notification is working. For example, this is the, let me show you. Okay, this is the CloudOps workflow, right? As you can see here, we have like a self-service Nexus service, notify signal operation. So basically, we have abstract the Slack notification features in another namespace. If I go to the platform, so basically we have a shared like platform namespace. If I click this, you can see this workflow is actually the workflow that powers the Slack notifications to different team, different channels, a lot of users. We also leverage GBT to help, render, like, to make sure on the Slack side it is like a beautiful like fog. So basically, we can add a lot of features here to do some improvement within this workflow without, like asking people to make any changes because we manage this like self-service notification workflow. So basically, I kind of just demo like how Nexus is enable us to basically like each namespace, you can just focus on whatever your workflow is working on without caring about others' implementation, as long as you have the contract. And with that, we can share a lot of features we're working on. If you want to, for example, for example, like we use Terraform to manage the database cluster array. So after that, it will call another workflow via Nexus to create a PR to remove the Terraform code. So we can basically have a lot of basic workflow and glue them together. Yeah. So yeah, this is my demo. I'm gonna just go back here just to give you a sense. Yeah, I think that's it. I can also share the Slack notification I just mentioned. Yeah, maybe just self-service notifications. Yeah, this is the one. For example, I just trigger a delete RDS workflow, right? So this is the Slack notifications. We have basically um, so this is how we're gonna communicate with the service owner who triggered the workflow instead of like manually Slack them. And they can click this button to go to Temporal UI, and they could also view the logs through our Grafana. So for example, they can click this button and go here and view the logs. And you can make it like 30 minutes maybe. Yeah, so as you can see, you can see the logs here. And there's not a lot because it's just like basically a database. Yeah, but this is our system. Just to recap, we have a portal that calls a microservice trigger like a gateway router workflow, and the router workflow will basically call different options, which essentially another workflow in the target namespace. We basically build this infrastructure so that engineer can easily add build their workflow and also expose their workflow through this portal, which increase a lot of velocity. As you can see, there are a lot of workflow from different teams for different use cases. Um, yeah, we hope that our engineer can add more and more. We really love automation using Temporal. Yeah, that's my sharing. Um, oh yeah, I need to go back to my slides actually. Um, slides. Where is it? Let's see. Sorry, actually, I just skip out of that. Yeah. Oh, okay. So just a very simple recap. So basically, Nexus let us keep our names isolated without paying the operational tax. That's what temporal team called. So we don't have to make them talk to each other with our own implementation because it just works. Like we mentioned, this is pretty secure because you can have your own namespace access, right? And you can also easily do like cross-team collaboration, and it is reliable because Temporal handles the retry by themselves. This is really like a doable experience, and it also reduces a lot of engineering overhead. So, like you see in the example, we didn't wrote so we didn't write a lot of codes actually. We just need to set up like a pattern, and the engineer will just adopt it. And yeah, basically that's I mean, overall, I think it's a very good experience. I think Nexus team had a lot of plan, which will basically even simplify the setup. Um, so we're pretty looking forward to that.
Awesome, Jihao. That was fantastic. Super cool to see what Duolingo and y'all are doing with Temporal and Nexus over there in the self-serve portal. It just looks really awesome. Cool. So we're going to transition into the back half of the webinar and talk about, what's next. So today, you can reliably connect workflows across any namespace within Temporal. But next, we're really focusing on making Nexus calls from anywhere. So just like, Jihao basically showed with the Duolingo, microservice gateway that was basically like kind of outside of Temporal and kind of integrating with other apps, other services, like even being able to make calls from like Bash scripts or, Postman. So you'll see this coming online in Nexus, starting with the Temporal SDK client. So you can use that inside of like a UI backend, a BFF, a non-temporal microservice, et cetera, just by importing temporal SDK and then using the client to start Nexus operations. So we'll chat about that. But also exposing entry points for HTTP, Kafka, MCP, gRPC. So really being able to make Nexus calls from anywhere. But also being able to integrate non-temporal services. So you might have existing services like, REST or Kafka or gRPC in your organization, right? And bringing those into temporal with a Nexus facade, or even like services that you use like GitHub and Jira and RDS, like, Jihao showed in the demo. Um, and so then from within your workflow, you just get a much better experience, right? Where you have these Nexus services that are available built once, available to everybody, with a Nexus endpoint. And then any workflow can consume those with no activity wrappers, just invoking the Nexus operation directly. So if you look on the right-hand side, today we have workflow to workflow within Temporal. Non-workflow callers is next using the Temporal SDK client. And then what Jihao was calling, kind of the temporal gateway, we're calling these Nexus connectors. And so focusing on both inbound and outbound connectors and getting the foundations, which we'll chat through here in a second. And then building some Nexus connectors for y'all on top of that for popular services and protocols. So non-workflow callers. So this is what we're calling standalone Nexus operations. So you can make Nexus calls from anywhere, using the Temporal SDK client. And what it lets you do is durably hand off the execution of a Nexus op to Temporal, but you don't need a caller proxy workflow like Jihao was showing in the demo. We could actually just invoke that directly. And what's really nice about this is that you get all the automatic like retries, you get the visibility, you get the built-in rate limiting and circuit breaking and all the things you would want to ensure that like you can say, hey, go execute this Nexus operation. And then, you can go to the beach and chill, and we'll just let you know when it's done, right? So that's basically the standalone Nexus ops, starting with the Temporal SDK client. And then this is part of what we're calling the Nexus Connector Foundation. So standalone Nexus ops, if you're building, a Nexus connector, like, Jihao was building with the, temporal gateway to expose to other teams in the organization, non-temporal teams, right? Um, then you'd use those standalone Nexus ops to do that via an inbound Nexus connector namespace, but you don't need the proxy workflow. It just uses this as the API that it talks to, and really you're just using the Temporal SDK client to execute that Nexus operation. But then if it's a longer running operation, you might have an async response that's coming back, and if you're like an HTTP connector, you like, oh, I want to send a webhook, or if I'm a Kafka connector, I might want to like put a Kafka message onto a topic. And so having multiplex callback support is part of what we're calling, the inbound connector foundation, so that you can build these, connectors, these inbound connectors to adapt to, popular protocols that you might have in your environment. So that's the inbound side. The outbound side is really focused on getting to like a streamlined workflow developer experience where imagine that you just deploy a handful of connectors into your environment and they're up and running as Nexus services. And then teams can just use those from their caller workflows and they don't need activity wrappers. They don't need anything. They can just write the workflow. And it's just much simpler, right? And much cleaner. And as we'll see here in a minute, we're adding support for like API first contract development. So it's going to be even more delightful kind of on top of that. But this is basically where you're kind of like getting a Nexus facade for your existing APIs that you have the option of refactoring behind at some future point if you so choose without disturbing the caller workflows. The ability to invoke unreliable APIs. And then being able to like manually complete Nexus ops. For example, let's say that you have, like a Kafka service or a legacy job service that's sending a webhook to notify on completion. Well, you want the caller workflow to just get that, via like a Nexus operation completed so that they get the like native temporal experience, even though they're using non-temporal services. So this is basically the connector foundations for kind of outbound Nexus connectors. And then taking all of this together and building a set of Nexus connectors so you can connect faster with popular services and use protocols that you might have in your environment, and otherwise just kind of integrate more broadly. So the API first developer experience. So we have kind of a Nexus IDL or schema definition that's very similar to like OpenAPI. We're also working on one for gRPC style with kind of annotations. And you basically get, a polyglot code gen experience so that you can quickly get up and running, with like a worker implemented in Go and a caller, implemented in Python with a fully typed experience, and then being able to publish those to a service registry or hub with auto-generated docs and the ability to grab those contracts and do the code gen and get up and running super fast in your environment and see which services are running where, and that kind of a thing. We're also working on a set of advanced operator visibility and control features, focusing around like running shared services reliably at scale, seeing who's using how much, are they running into errors, setting rate limits on a per caller basis, as well as doing like auth policy at the service and the operation level for finer grained auth, and then doing things like advanced routing rules across multiple targets. Today, Nexus supports a single upstream target namespace and task queue. And so supporting multiple targets and then having routing rules by like service name or header, those types of things on that front. So in summary, kind of across these buckets, you can, connect today kind of across workflows within Temporal. Standalone Nexus Ops brings that to non-workflow callers. We got the connector foundation, so you can build your own connectors using those capabilities. And then we'll be building some as well, and would love to partner with y'all in the community on building these connectors together. All the SDKs are basically going to GA in the near future. A set of SDK ergonomics around making it even easier to do things like sending a signal, doing an async update from a Nexus handler, and getting kind of deep bidirectional linking so that you get the execution debug, not just across workflow start, but for every single Nexus, message that's sent. And then the API first contract and code gen, the service registry, and then on the ops front, multi-tenant visibility, rate limiting, fine-grained OSI, and then the enhanced routing rules. So we'd love your feedback. I think we have a set of poll questions that is asking you like, okay, if you had to pick your top few things on this roadmap, like what would those be? Like which SDKs are you using? Are you like not seeing things on here, like a fill in the blank? So I think if we pop those, Hannah, the poll up real quick, then we can get folks to do that. Awesome. Yeah. So go for the poll. After we get enough responses here, then we'll switch over to Q&A. Yeah. And so just a couple questions on the chat. So everybody universally loved the demo. So great work, Jiao, on that. Um, Sample code for creating router workflows. Yeah, so we're going to be documenting that. I think we have all circle back there. And then, yeah, it's basically very easy. You just set the target task queue in the workflow start options, and then it just kind of starts it on that task queue. So there's not a whole lot there, but we can definitely do that. And we do have the cloud demo that's showing that. I think I could probably bring that up really quick. Um, and then let's see. So Kafka topic to Nexus. Yep. So that'll be like an inbound Nexus connector for Kafka. Oh, cool. Yeah. Thanks, Justin. JD. Similar to standalone activities. Yeah. So standalone activities is basically what's going to support um, invoking unreliable APIs. And so when you have like an Nexus handler, that's really focused on like invoking like a reliable API. And so if you want to invoke unreliable APIs, then you'll want to basically combine a standalone activity with a Nexus handler. And that's something that'll be coming into pre-release here in the near future. So stay tuned on that front. Catalog for Nexus connectors. Yeah, so the catalog for Nexus connectors is the service registry. Um, and so that'll kind of expand over time to do that. But for now, I think we'll just have probably like a repo where those connectors will be living. Can't wait to start testing it. Thanks. Um, Great. Canary deployments.
Um,
Yeah, so canary deployments is a thing as well. Um,
I think there
Great.
was another question in the chat too. I believe it's for Zihao or Jihao, sorry, apologies. Just are there other ways you approve the workflow that's not through the temporal UI, but say through Slack?
Yeah, I can answer the question. So like I mentioned, we create a microservice to trigger the workflow. So we also support using HTTP requests to send a signal or send a query or even send an update. Basically, it's a very thin wrapper for the Temporal SDK, just because we couldn't do that using HTTP, so we create a wrapper. To answer your question, technically you could just basically from Slack call an API endpoint to trigger that. Or if you could like build a Slack app. I mean, I haven't done this before, but technically you can even build a Slack app, right? But within the Slack app, you could either call a TV endpoint or you can initialize temporal client to send a signal. But essentially, you're gonna send a signal to temporal cloud. Yeah, but you can build whatever on top of that. But I don't. I think it's more of a question for like temporal Nexus team. Can we just send a signal to the workflow? Can we wrap
Uh,
a signal as an operation? I think we can, right?
oh, totally. Yeah. So, yeah. So, I mean, today, so I'm sure the question is, can you just reframe really quick?
I
Just,
think the question is like, can we, for example, like from Slack, just click a button to approve the workflow? But essentially, it is like a signal. So I
mhm.
assume you can wrap a signal as a temporal Nexus operation, and you can just trigger that operation to approve that.
Totally. Yeah. And
Yeah.
so basically today you can use like a Nexus handler to like start a workflow, to send a signal, to do a query, do an update. Basically anything you can do with the temporal client, you can do via Nexus. And then, as part of like the SDK ergonomics, we already have like a SDK helper builder function called like new workflow run operation that, Jihao was showing in the demo. And what that does is it automatically wires up the Nexus callback for you automatically. It automatically wires up like the bidirectional linking. And it just provides kind of like a much like streamlined experience for that. So we're going to be bringing that to things like signals, like async update, query, like all those things, so that like when you send a signal via Nexus handler, which you'll do like a new sync operation, and then today there's like on the context of the sync operation handler, you can just say get client, and it'll get an initialized client in the same namespace. So then you can basically just say like get client and then send signal and then you're done. So like, super small amount of code. But then what the ergonomics are going to provide is like a specific helper builder for like new signal operation. And then it'll go ahead and automatically wire up the bidirectional linking so that you'll be able to click the links across those boundaries and say like, oh, I sent the signal and then take me to the exact place in the handler workflow where the signal was handled so I can like step through the debug and do that. Yeah, so there's a couple questions on encryption. So just a couple things here, right? So when you're sending a payload via Nexus, it uses the same data converter that Temporal uses for workflows and activities. And so what that means is when the payload is being sent from the caller to the handler or the sender to the receiver, that's going to be encrypted with the caller's data converter and codec, and the codec is where the encryption keys are usually used. And so, if you're using the same encryption key on both sides, then everything just works. But in many cases, people want to use separate encryption keys on separate namespaces. And so, how is this supposed to work with Nexus? And so, what you can do is you can pass let's say you're using KMS, AWS KMS or Vault, right? And there's like an ID that you're using to basically like encrypt the payload, right? And so you know what the KMS ID is. You can pass that in the payload metadata, and we have an example. I can drop a link. Um, and then basically, and if you just go to like the samples on temporal samples repo, it'll show you like how to flow like in the encryption example, like the KMS IDs. And so that just flows across in the payload metadata. And then on the receiver side, its data converter is going to like process that payload. And then it'll be like, oh, I'm using this codec with this, which encryption key should I use? It just looks at the payload metadata, which is like a map, and then it gets the KMS key ID out, and then it just needs decrypt permission on that. So, this works well for many folks that are working like within an organization, within a company, right? Where you're using KMS and that kind of a thing. But you can also, have a separate encryption key just for Nexus. It's a little bit more advanced right now. But you can either flow context or you can use like wrapper types. So that the data converter can look at those wrapper types and then get the Nexus endpoint and then use an encryption key per Nexus endpoint. So, hit us up in terms of like your account team or on community Slack to kind of learn more about, that option, the separate encryption keys. Um, but yeah, if you do the first two where it's like the same encryption key on both sides, you're just flowing the KMS key ID and payload metadata in both directions, then it just works and you don't really need to do anything fancy there. So, um, awesome. Cool. Thanks, Justin. Any other questions? I think we made through everything. Cubby, how are we looking?
Yeah, I think we have a couple minutes left. I think I will definitely like if there are more questions, Hannah posted the link for our community channel. So feel free to ask any questions there and we'll get back to you if you have any follow-ups. But yeah, I think just to close this out, then, as far as next steps go, we'll send out the Zoom recording and deck as well, so you can have this as a resource. We'll also, you can see in that second section, we have tons of resources about learning Nexus fundamentals. You can learn about how you might evaluate if Nexus is the right fit for some of your use cases, and then learn about the concepts and everything as well. And lastly, we also have our community monthly newsletter where we send information like this, and you can stay up to date with all of these resources. So, oh, I think I lost your data
Sorry.
there. No, no,
Yeah.
you're totally fine. Yeah, and then I think lastly, just as a pitch, we will be having our annual conference. So this is called Replay. It's going to be happening in San Francisco at the Moscone Center. Phil, if you don't mind just clicking two slides over. Thank you. Yeah, feel free to join us. We'd love to see you there. If you enjoyed this webinar, we'll be having a lot of other talks that are talking about topics like this. And with the code webinar75, you get 75% off your ticket. So I think that's a really great discount and would love to see everyone there. But I think with that, we are all set. And yeah, we'll be sending out the Zoom recording link shortly. Thank you all for joining. And thanks, Jihao and Phil.